Okay, so far we've talked about how to use the Pythagorean theorem to decide whether or not the triangle is a right triangle, and we've used it to decide if we have a right triangle, the lengths of either the missing hypotenuse or the missing side, the leg. Now we're going to put them together and see if we can use them to solve word problems. To do a word problem, you first have to read the problem, figure out what it's asking for, and make a drawing. The drawing will help you see the triangle, it will help you see the right angle, and that will help you label the three sides. Okay, particularly you want to make sure you label the hypotenuse correctly because C is always opposite the right angle. Here it says that Stephanie is planning a right triangular garden. She marked two sides that measured 24 feet and 25 feet, and we want to know the length of side N. So the first thing that we're going to do is draw a picture. So that we have a picture of the garden, all right? We see the right triangle, we see the 25 feet, we see the 24 feet, and we see the missing side N. Next step, we're going to label. Now, C is always going to be, remember, the side opposite the right angle. So C is right there. We know C. All right? B, okay, A is always going to be the shortest side. A, in this case, is the missing side N. And B is going to be the next side, the one that remains. Once we have it labeled, we realize that we're missing A. We can write the Pythagorean theorem. A squared plus B squared equals C squared. We can substitute the values that we know, 24 for B and 25 for C. We can do the math, means squaring 24 and squaring 25. Okay? And now we have to solve the equation. This is a missing leg problem, so we're going to have to subtract something from both sides. Here, it's it's 576. So we'll subtract that from both sides, and we'll get A squared equal to 49. I take the square root of that, and it gives us A equals 7. Now, our final step, since this is a word problem, is to give a word answer with units. The length of side N is 7 feet. All right, let's do another problem. A builder needs to add diagonal braces to the wall. The wall is 16 feet wide by 12 feet high. What is the length of each brace? Again, we're going to draw a picture. Okay, there's the wall. There are the two diagonal braces. The key here is diagonal. The diagonal are the ones that represent the hypotenuse. That's the one that we're missing. We know that the wall is 16 feet wide. Okay, so this measurement is 16. That's B. And 12 feet high. That's A. What we're missing is here. That is C. All right, we write the Pythagorean theorem, and we say, okay, we know A and B, we don't know C. So we can substitute 12 for A and 16 for B, and get 12 squared plus 16 squared is equal to C squared. We'll do the math, and in this case, we can just add them up together to get 400. That's C squared, but we want to know C, the measurement of the diagonal. We take the square root for both sides, and we get C equals 20. Again, we write our answer as a complete sentence. Each brace should be 20 feet long. Here's one final word problem. Two trains left Metropolis at the same time. One traveled south at 50 miles per hour, the other traveled east at 40 miles per hour. How far apart were the trains at the end of 3 hours? So we're going to have to make our own drawing for this one. All right? We'll put one line that represents the train going south. All right? It went there for 3 hours, and it went 50 miles. So that's going to be 150 miles going south. It went east at 40 miles per hour. How far did it get in 3 hours? It got 120 miles. So that's this side. You'll have to remember that south and east are at 90-degree angles to each other. So this is going to be side B. This is going to be side A. And they want to know how far apart were the trains. That's going to be the one we don't know. That's going to be this side. There's your drawing. You'd label this one A, this one B, this one C, and solve using the Pythagorean theorem.